You guys are there? Okay. Hello? Available?
Yes, ma'am.
Almost. Okay. Right. Okay. So today, what I was going to discuss is the last class. You have a brief idea that we have some address lines, we have some data lines, we have some control signals, right? Today I will try to accumulate everything and try to explain you when a processing work is being done. Okay, if at all we understand how a processing or a code is being executed, then the architecture of it automatically we will understand. And today, though it is like from the internet sources only, I will show you in sets how exactly we will work out. Okay, now I will just try that we have address lines which are 16 lines, right? And that combination of the 16 lines will access 65 something something, which is rounded up to 64 kilobytes. Is that correct? Yes. Then data lines is that 8 data lines, right? So now GPR means general purpose register, which is 6 registers are there. I already gave you B, C, D, E, isn't it? Accumulator, then flag register, yes or not? And this is PC. PC is the program counter, which comes as the special purpose register. 2 more are there, stack pointer, and another one is what? I forgot. What's the other one? Stack pointer, what's the other one? Nobody remembered. Huh? Seriously, I forgot, because 86 and 85 both will be like, for me, this one. Wait a second. What is the last register? Wow, I seriously forgot. Program counter, stack pointer. Only 2 are there. Yeah, only 2 are there. Isn't it? Only program counter and stack pointer. Anything else is there? Third one? Hello? You guys are there? I am not there.
Yes, ma'am.
Yes. What is the third one? Is that third existing? One is stack pointer, the other one is what? Only that 2, isn't it? Only these 2 are there. Special purpose register, general purpose register. Please try to concentrate now. Okay, focus. Now, for example, if at all we are trying to execute an instruction. Now, the word is coming as instruction. Now, instruction means what? It is a task to be performed by the microprocessor. That time, how exactly the scenario works, right? Whenever an instruction is given, right? Last class I have given you about read, write, then afterwards IO in and IO output, right? Did you remember memory read, memory write, IO read and IO write? Did you remember? Please give a feedback.
Yes, ma'am.
Right, hold on. Keep your unmuted itself, no problem. Right. So it can be in any category, doesn't matter. If an instruction is provided, how exactly these address lines, this data lines, and especially this registers and this one, how they will do the work. That I am trying to explain. Please try to hold on. I mean, concentrate here. Now, the memory looks like this. Briefly. Okay. This side will be the address. So, address will be how many lines? It will be 16-bit. Definitely, it will be 16-bit. Now, let me show you the diagram and parallelly I will explain you here. Though it's in this one, just a second. Now, just don't get confused with the that address, top line. Okay, what's the written? Data flow from the memory to the MPU, right? Afterwards, something is there. Okay, now let me tell you that move C, comma A, something. That is an instruction. Afterwards, I will tell you what is that. Now, consider that is an instruction to be operated or to be done by the microprocessor. Now, how it will execute? If you can see there in the screen, what is that? This side you have a memory, isn't it? Now, if you can see, there are there are 2 divisions in there, 2 columns. There is one portion which is exclusively for the address, and the other portion is for storing something. Okay, data stored. Now, concentrate there and tell me in the first half, what will be the number of lines required? See, address means what? Address means what? 16 values will be there. I mean 16 lines are there. That means how much will be the address bit size? It will be 16 bit. When they coded in hexadecimal, it considers. For example, this is 0001H. So this will be 0002H in hexadecimal. Isn't it? It will be like this. So FFFH. Is that fine? Please acknowledge. Is that correct? Is that correct or not? You guys are there or not listening? What is happening with you? Why are you not responding? Somebody at least please respond so that I will continue. Anshuman?
Yes, ma'am.
Yeah, you guys are following?
Yes, ma'am.
Yes. Now hold on. So, whenever an instruction has to be executed, first and foremost option is fetch. Okay. Now, the words you please try to pick up. Fetch means what? Fetch means it has to go and get. Now, where to go and what to get? These two options comes into picture. Now, we have to understand that the one which is here, this is very important. Who is this? It's a special register, special purpose register, who is called the program counter. The program counter is the first initiation or the first control signal will come to the program counter, which will tell or which will dictate, go to the memory location. Right? So, when the memory location address will be placed on the line. So, on the line means what? Address lines. Address lines are how many? 16 lines are there. So, it can carry a hexadecimal of 4 digits, isn't it? So, program counter on the address lines, this is address lines, that will go to the location. Right? When the location it will be pointed out, what will happen? Whatever is there here has to be fetched through the data bus. This is data bus. Right? And then that data bus will be targeting to the instruction register. Now carefully understand, I am using a lot of technical words. So the word fetch is go to the location, go to the memory location, fetch whatever is there in that location. I am not guaranteeing that there is a data inside that. We are saying that it is a data. That's all. Now, carefully understand. On that one, it is written that 14F move B comma C, isn't it? That's the word given on the slide. Yes or not?
Yes, ma'am.
Right. Now, what is happening? First, try to understand. This particular one is an instruction, right? That is an assembly language instruction. Now, if you understand here, what is the meaning of MOV? Move. Move B and C. That means move the contents of register C to the register B. That is what it should be understood. Okay, hold on. This particular instruction won't be stored like that. It will be stored in a form of opcode. This is called opcode. So, I told you earlier itself, the assembly language program is already instructions are framed as opcodes and is registered already. Right? So, now, for example, if this one is having 14F, what does it mean? This 14F will be transferred onto the data bus. Data bus is having 8 bits only. It is very well known. So, that will be coming here and go to the instruction register. Now, from there, it will pass on to instruction executor or instruction decoder release. Please try to understand. You fetch the opcode or data, we will say, then afterwards place in the instruction register, then afterwards decode it. Now this is how it has to be executed. Any instruction. Now here you can understand clearly the control signals are the one which are instructing everyone. The control signal instructs first the program counter, the addresses will be enabled, the address lines will go and search for the memory location. Then the data bus will be triggered. Then the data bus will try to fetch whatever is there. Then put it in the instruction register. Then the instruction register afterwards, it will be going to the instruction decoder. This is completely the same thing. We can understand that. No problem. So instruction decoder, what its job is, it decodes whatever it got. So this got what? 4F. Now 4F means it is again trying to memorize. What does 4F means? So it is an opcode. So when an opcode is there, then it will go and check its list. Oh, opcode 4F stands for move B, C. So that job will be performed. Are you able to understand? The operation fetch the data, store it in the instruction register, decode it, and then understand. Here in this all rows, the control signal control unit is also there. The address lines are there and the data lines are there. Everything is working sequentially. So once the job is done, what happens? The next instruction will be again sent to the PC. Who is PC? The program counter. The program counter increases its location. That means earlier it has an old address. Now it has to move to the new address. So it will again try to move to the new address and does the next job. Right. Now you can think, when the instruction is being decoded, what the program counter has no role in that. So it can be readily increased and checked. This one, program counter can be incremented. And the next location it can point out. Please try to understand. This is the small parallel process going on here. When the instruction is being decoded, program counter has no role. So the control signal will already indicate program counter to go to the next location. That's how the instructions will be worked out sequentially, one after another. The program will never be executed randomly. It's always in the sequential mode. Now I think you should be having doubts. Please open up. Yes. If no doubts, then I will have to rush. Please tell. Please something or other should be there. Forget about ALU. I am talking about control unit, then the resistors, then what the program counter does, and the memory. I mean, you guys are okay with this, or something else has to be told? Nobody has any doubt?
No, ma'am.
Fine. So here it is. Kaluna, Pooja, Arpita, what happened? No doubts at all. You should be at least asking me what is the opcode. Opcode stands for what? I'm just missing it. The flavor of my teaching on all, I'm missing it. Opcode stands for what?
Ma'am,
yes.
Ma'am, the video and audio is lagging actually.
Oh, who is that, ma? Who told now?
Ma'am, Shweta.
Shweta. Excellent, Shweta. After I completed. Now tell. Any doubts in that? Video and audio is lagging. It's fine. You might have enjoyed the show. But you didn't get any doubt? Opcode stands for what? Yes. Opcode. Yes, ma'am. Opcode stands for what? Huh?
Specifies the operation to be performed.
Oh, specific operation to be performed. Okay, that means opcode stands for operation code. That's an acronym for opcode. Right. So the acronyms only will be stored here. That is what I'm talking as the data. Okay, now hold on. I'll tell you another thing. Now I am slowly introducing this MOV, this one. Now I'll tell you something to perform. 2 plus 3 equal to 5. Okay, normally this is the process to be done. Okay, now 2 is one variable, or sorry, one fixed value, 3 is another fixed value. This is the result. You will agree for that? This value plus this value equal to this. Hold on. Now, this one is called, these two are called, this microprocessor language, operands. Okay, please unmute and keep better. You are not listening also. These are called, these two are called operands. 2 and 3 are called operands. This is called result. This is called operation to be performed, which is nothing but add. Okay, now, if at all I want to do this work in the microprocessor in general, normally I have to use the assembly language coding. So, ADD stands for addition. This is already add, means it will understand. But hold on. Now, add 2 plus 3. I cannot write 2 plus 3, 2 comma 3. I cannot do. So, that means I have to store 2 in one register. I have to store in another register. Then do the operation. So, that means add B comma C. Okay? Is that fine? That means consider that inside B 2 is already placed. Consider it. Inside C 3 is already placed. Then you will perform the add operation on these two. Right? Is that correct? Yes or no?
Yes, ma'am.
Hold on. But this is wrong. This is wrong. Never any action is done without the involvement of accumulator. I already told you accumulator A plays a very important role. Please try to understand. Okay, now this is never asked. So add B. What does it mean? The contents of B are added to A and the result is stored in A. This is how it should be done. So, like this I will show. The contents of B, which is 2, is placed in B, and the contents of A, we don't know who is there in A, but it will be added to A, and the result is stored in this. Now, add. Now, as you told, if this is in B, this is in C, add C. What does it mean? From B is added, and the value is result is stored in A. Then afterwards, A plus C is done and it will be accumulated again in A. Did you understand why the word is called accumulator? It accumulates the results. Add C. That's it. So 2 plus 3 will be added in this manner if you are using this one. Otherwise, simple option. That's it. So with these 3 instructions, you can easily perform the addition of 2 and 3 and the result will be already in the A. Did you understand here what did I write? I wrote 0, 2 because my operation is fixed. I have to store 0, 2 in A, 0, 3 in B, then add B. That means A add B means A plus B and result is stored in A. So this is the small code which is actually performing this operation. 2 plus 3. Now you can ask doubts. If I change this value, yes, if you can change this value, change here. Change here. If this is 8, change here. Enter. You can enter it. The data can be entered. Is that fine? Is that understood?
Yes, ma'am.
How this is performed? That means the registers, this is the operands. And now you can understand the importance of accumulator also. Every time the accumulator is the one which plays a very important role. That's what the other time I told. It's very close to the memory. So accumulator does the most of the job. So one of the operand has to be in the accumulator. That's the best way. accumulator takes the first operand, then the next another register will be taking the next operand and this one. But hold on, this particular one all will have a set of opcodes. Okay, now opcode for this will be there. So something, I don't know, opcode will normally in 8 bits more. So I can say this will be XYH. You are not getting any doubt also here. Just see, if this XX will be there here, XX will be there here, how do XX hit? But 08 is not there, no part of that. How it will be understood? That data has to be stored also, this also has to be stored, no? 08 has to be stored, the program counter is pointing to this. Right, so next it will point out to this, but here I have to store 08H. How the program counter will understand that we have to leave a location? Hello? Are you able to understand? Here what is happening?
By address.
No, by the opcodes. By the opcode. See, carefully understand. A opcode is a word, operation code, which will distinguish or gives an idea to the program counter whether it has to be incremented by 1 time or it has to be incremented by 2 times. This is a very crucial programming. Hold on. When the program counter is instructed to be incremented, always there is a tagline. It has to be incremented by 1 or it should be incremented by 2. 1 it can come if at all no data has to be stored. That also is an indication through the opcode. If data store is not there, like the earlier one, B, C, this one is not having any data to be stored. So the location has to be incremented. Next execution will be 1 increment. If like this is the next execution, it will increment 2 times. Why? Because 0 also has to be added. So every opcodes, the way it is framed, always indicates if a direct data is entering or it is coming through a register. If it through a register, the increment will be 1 time. If a data is also coming, that means increment will be 2 times. That means next location has to be shared with the data to be taken. Please try to understand here. Very crucial. You are trying to get that. Like it's just like reserving the seat next to you. So first location, then the next location. Whether it has to, program counter has to be incremented 1 location or next. This indication will be given by the opcode. Are you able to understand? Little confusing, but still. Okay, now hold on. If this program counter, I wanted to increment by 4 times. Can I do that? The location address, memory address has to be incremented 4 times. That means I want that to jump from here to this location. Can I do that? Yes, I can do that. How? I have an instruction called JMP. JMP and give the location. It will jump there. That is how it will jump to the location. But you should be understanding the location. Please try to understand. It is a very, very tricky programming. Because it's not like the normal compiler work. It goes with the memory locations, and the number of memory locations it has to be allocated. And all the time the program counter is the one which is taking care of everything. Program counter points to the memory location, gets the data from that, then fetches the data, then does the opcode work, then afterwards stores in the instruction register, decode it. Here it will understand what it has to be done. So when the decode is readily done, that time program counter will already get a hint. So it will increase 1 time or 2 times, automatically it will be controlled. Please try to understand that way. So when the decode instruction register will be checking out what instruction has come. When this particular 4F is getting decoded, hint will go to the program counter where exactly the location has to be moved. Either 1 time or 2 times or 3 times or 4 times. That's it. So next sequence will come. Next instruction will come. Next instruction. Fetch, then up fetch, then afterwards instruction register, decode. All these things will go on in a continuous sequential mode. Are you able to understand this? At least? Yes or no?
Yes, ma'am.
AMP,
Yes, ma'am.
Ma'am, the JMP takes the location in which format?
Yes, always jump here everything. If it is a memory location, that's why I wrote 1, 2, 3, 4. So you can understand it's a hexadecimal. See, processor is all with hex. It will be only in a byte form or a 2-byte form. That's everything you will understand in that only. A byte form or a 2-byte form. Memory location always in this. JMP, jump. Very interesting instructions are there. We will really enjoy them. So I wrote 1, 2, 3, 4 lines. Means how much? This one, lower order, higher order, address lines only, na? So address lines are what? 16, A0 to A15, isn't it? If you remember, the lower order,
Yes.
AD0, yeah, AD7. So this particular half is the lower one, which acts as both address and data, and the second one. So total one jumps to this location. When it has to be switched on to data, when it has to be switched on to address, it is controlled. Don't worry. It's just like our brain. So brain is what? It is sends a signal to so many different organs, isn't it? That's how the organs are working. Every time it happens like that only. See, it doesn't like when the brain is working, it sends two things. I'm writing here and talking also. No? That means my brain is concentrating this side as well as this side. It's like that. Controls are in multiple, and every organ will be doing its work, and we will accumulate all those, not accumulate, and maybe we will centralize all those things. But if at all I will show the diagram, it will be shabby. So hence I am doing it in arrow marks. Okay, so jump will always to be a memory location. That's a good question. It's to be a 16-bit address. Anything else? At least now let me show you the original diagram. Yes, you will really enjoy this diagram. Just read. You are having an introduction to so many things. Forget about the inputs and all those. That yellow color one is the familiar one which you already know, right? Then you have the internal bus. Then you have what else? Control, status, everything. That is called timing and control diagram. The block. And the time and control one is the one which does the execution. But it doesn't mean that it's not connected. It's not hanging in the air. It is well connected, circuited. Okay, if I try to draw the lines, it looks sharp. So one important one here is time and control. We will say time and control. Why? That x1, x2 is there. No? Between this only, the timing circuit will be there. So between this only, oscillator work. RC or normally crystal oscillator. What is crystal oscillator? Crystal oscillator, it gives timing signals, no? Isn't it? So time and control. So these are very important. So with the time and control signals, who else are there? Just see. Please read out. I cannot see. Who else are there? Ground is there, 5 volts. That's forgetting. What else is there? Guys, RD means? Do you guess now?
Yes, ma'am.
No, do a guess for what is RD?
Read.
Yes. And why there is a hyphen here? Why there is a bar? Always remember, I'll tell you. This is also a logic. Read this one. Okay. So read with a bar means whenever a zero signal is sent, it is activated. Okay. You know the logic, no? Logic 1 and logic 0. It doesn't mean that. See, some work as logic 1, some lines works as logic 0. Isn't it? It's just the what? Activation. Read is activated with 0. That's why there's a RD cap bar. Did you understand that? RD is having that?
Yes.
RD is having? Yes. Then who else is having?
WR.
WR. WR stands for?
Right.
Excellent. So it's right. This is also a negative one. Okay. See, Intel has processed. It's a very commercially successful 8085. So they have manufactured like this because it's not like an illusion I am telling. It's like two things which are exactly connected. So it's exactly the one which I am trying to explain, which has been worked. So in the market. So that's why we cannot change that scenario. So read works with a negative logic, write works with a negative logic. Is that fine? So negative logic and this is also negative logic. That's how go.
Ma'am,
Please.
is it associated with SOP form like we have?
I cannot really say that. Okay, SOP form is again a Boolean function, Mama. It's a big one. So many functions together. SOP and POS, they are complement to each other. That's what you are telling. Is that Sulagna or Shweta? Who is reading?
Shweta. Ma'am, I was thinking, I'm Shweta.
No, go ahead.
Ma'am, I was thinking that maybe like we have a bar for 0 in SOP form. So like that.
For your level right now, you take that only. Okay, but what happens is, see, when we have so many lines, active high and active low. Okay, active high and active low. Just like a clock signal. Yes, I can tell you this. Some circuits work this side, 0 to 1. Some circuits work this way, 1 to 0. This circuit also is correct, this circuit also is correct. Both has a connection in a correct manner only, but some works like this, some works like this. Is that okay? No, not satisfied. I'll tell you. In a class, right? Those who have written the assignment, please sit down. What does that statement means? Decode it. In the class, who has written the assignment? Written the assignment. Please sit down. What does it mean? Who didn't write has to stand up, no? Shweta, is that correct?
Yes, ma'am.
So,
Yes,
then,
ma'am.
other way. Who has written the assignment, please stand up. That means, who has not written will sit, no?
Yes, ma'am.
Both ways it is correct only. I am trying to bifurcate the written, who has written the assignment, who has not written the assignment. Both ways the logic is correct. I have classified.
Yes, ma'am.
Correct, Shweta? Is that correct? Both ways I want to classify the people who has written the assignment and who has not written the assignment. That way also I can classify, this way also I can classify. This is how the control signal read and write for a particular 80 commercially successful 8085 wait with a low, active low. Read and write when they are low, that means it is doing the operation. When they are high, that means they have done the operation. This is how they are bifurcated. It's a technical aspect which is already with the commercial system. It's already in the kit. The kit works like that only. Shweta, you can design a kit with the other one also. Read with high and read with write with low. High. Is that fine?
Okay.
Yes. Okay. You should design. Okay. Now just see. Then what else? Okay. Afterwards, what is this status? S0, S1, IO, memory. What do you mean by that? Very complicated one. S0, S1, IO, then memory. Now, first two things, S0 and this one. What is this S0 and S1? Two lines are there, isn't it? Two lines.
Ma'am, are they select lines?
Yes, select lines you can say. Very good. So the two select lines are what they are doing. I told already we have memory operations or we have IO operations. The two select lines have a choice between these two, IO and memory. IO is always active high. Memory is always active low. Did you see? Memory with this IO. So the select lines will be selecting either I am doing an operation of IO or I am doing with the memory. This is how these four are in the same set. Is that clear? Yes. Hello, darlings of second year.
Yes.
Please respond. Okay. S0, S1, select lines. Excellent. Between what they have to select, it should be selecting between IO and memory. That's all. Nothing much. Is that clear? Now, if you go, next is D and A. With that, two signals are there. One is input side, another one is output side. Like arrows are different, isn't it? D and A. D
Yes,
and
ma'am.
A. Somebody can Google and tell what is, yes, what is DMA? You can check out. You have Google with you? Of course, yes. Who is not without this? Isn't it? DMA stands for what? Dynamic memory allocation? I don't know. Yes. What does DMA stands for? Nobody is doing the Google work.
Direct memory access.
Huh? No. Something else. Please tell. D. D stands for what?
Direct memory access.
Direct memory access. Otherwise, dynamic memory location also we will tell. Okay, direct memory access. Wow. Now, what is this one? It has like this and it has like this. And to that, HLD and another one is HLDA. HLD is there, hold is there, completely. Very good. What is this? Direct memory access. Memory is accessing whom? Actually, it is accessing the accumulator. Hold. It will hold the accumulator. Signal is sent means accumulator will hold. Afterwards, the accumulator is holded. One acknowledgement will go back to the direct memory access. Then only the control signal will start the work. Please try to understand. That's why I also work like a microprocessor. I will be asking, please acknowledge, please acknowledge. Otherwise, microprocessor will not proceed further. The timing and the control signals will go step by step. Direct memory access, why it is written there? I already told the accumulator register is always with the memory. So every time the accumulator will be cleared up and it will be holded. All this work will be done. So every time the accumulator will be held, then afterwards, once the accumulator is ready, acknowledgement will go, and then afterwards the process will start. That will come to the D and A. Then who else is next one? Next one is very easy. Yes. What is that? Yes, darlings. Please tell. Last one. What is that? Reset now. Reset. What is the reset? Reset. Reset means whenever the program is executed, we should reset the whole memory system back to the pavilion. RS. Reset. And also reset in, reset out. Is it there? See, I have been using different ones, reset in and reset out. Both are opposite to each other. One is in means the signal is inside, and one is out means the signal is outside. Right? Now carefully understand. To execute a instruction, all these control signals are in action. All these control signals has to be worked on. Otherwise, one instruction is also not done. The earlier story, what I told, you fetch, do this one, decode it, get lost. It is of nothing without this control. This is the one who controls. Execution is done throughout the system. But in every part will have one particular job to be done. Final output will be in one, you say register or at an output. The whole system is involved in that. Please try to understand. If I keep on writing the lines now, it looks shabby. This is how the architecture is there. You have to understand that simply this control unit is having signal just like your brain. It is having what? It's attachment with every part of the body. Just like that, it is timing control. Right. So whenever you have to execute a instruction, everyone is involved. So do you have an idea now? At least timing and control, what is happening? Control unit, we will say it is unit. So from the unit, whoever comes out, I will say the control link or the control output or the control bus. That's all. So earlier, I think in the first class, somebody asked me, control bus is of how many bit length? Is that correct? Because when I use the word address line, then data line, they asked me about control bus line. So control bus is not a line, not a single line. It is having a group of signals which will be done in a pre-designed manner. Throughout it will be executed or throughout it will be utilized till we get, when we finally get reset. Total executions is done and the instructions are completed, then the job is done. That time, till that time it will be worked out. Is that correct? Yes or not? See, little hard to understand, but still this is how we have to work out. Okay, now if at all you go to the interrupt, topmost one. Here, topmost one, interrupt control. What is that? Yes. Hello. You guys are there?
Yes, ma'am.
So the topmost one is the interrupt. Now tell me, I'll tell you. It is like a property. In a class, if it is a live class, I will be happy if at all I have more interrupts in my class. That means throughout my teaching, somebody has to point out, okay, ma'am, what is this? What is this? So those are called interrupts. That means I can stop the work and then attend to them and then come. Now tell me how efficient the work will be when the interrupts are more or when the interrupts are less. See, this is a logical question. You have to be very, diplomatically answering it. See, I prefer the interrupts should be more. Why? Because every time I can have a check. At the same time, I will waste my time also. At the same level, I will waste my time in order to complete my class. But the output will be very efficient. Everybody will participate in the discussion and they will understand, okay, these are the pros and cons. So that's how the interrupts will work out. So here, even in the 8085 also, we have intermediate interrupts. Why? Whenever a sequence program is being executed, let us consider I have some 1000 code lines. Right, it is working out. My end result will be at the 1000 line. Okay, but intermediate I can have a checkpoints that is done through that interrupt control. Through those, just see there, what are those names? INTR, INTA, RST, RST 6.5, 5.5, 7.5 interrupt. How many? How many total?
6.
6, sir. I don't think it's 6. 5 are there and 1 is an acknowledgement. Did you see? INTR is inside. Okay, INTA bar is an acknowledgement which is coming outside. Isn't it? The
Yes,
right.
ma'am.
Yeah. So it has totally how many interrupts? Actually 1, 2, 3, 4, 5. It has only 5 interrupts. And then it has 5 interrupts only. These are the 4 interrupts. 3 levels are there and 4 interrupts. And then this one are the controls of this. Whenever first this is pressed means some of this will be activated. So once it is pressed, that button is pressed, okay, acknowledgement will be given, then one of that will be activated. So these two are not counted as a part of the interrupts. Basically, it has only 1, 2, 3, 4, 4 property. 4 interrupts. But when you go to 8086, it will be more. Now it is like huge. Because now the era of parallel processing has come. Na? It's no more sequential processing, if you remember, isn't it? Parallel processing, you heard? Multitasking. Yes or no?
Yes, ma'am.
Yes. Now, just think. Where exactly this can be utilized in a live scenario? At present, I don't think we can work out with interrupts because that comes in a interfacing section. So at present, that unit, no, you try to overlook that interface. Okay, now come to this one. Serial I/O control. What is this? Serial input output control. What is that? So it is something to do with the output device, input output device, isn't it? So these are external devices which are interfaced and kept. So SID, serial input device. SOD, serial output device. Serial input data also they will tell, serial output data also they will tell. So some books follow SID, SIO as device, some books follow as SOD as serial output data. That means it has to be with the IO devices. Now, if you can see that you have temporary registers, you have flags, you have arithmetic and logic units, and you have the signals to them, isn't it? Now, not only the signal diagrams like the flow, you can check out also the timing and control is with everyone. To be honest, without that, none of the things are working out. None of the things will work out without that. Now, if you can see the address buffer, the program counter is there. The program counter will be taking the memory value, location, address location, then comes here, then you can follow my cursor. So here and then afterwards enters into the data bus and then afterwards it will go to the work to be done in the arithmetic unit because most of the things are arithmetic and logic operations. Then all these are involved. Then finally the instruction decoding and everything is worked out. Then we will get the output. But this is about architecture, right? But we should understand the main property of this is with the instructions what it can work on. So that's where we will enter into the next domain. What is actually the instructions it has? To be honest. Okay, so now I don't want to feed you with so many things. We are going to mark up the whole instruction set. It's very interesting. Okay, instruction set 8085, we have an idea at least. So when we try to program that through these instructions, we will understand how the architecture also works. Since we have only a small idea on that, we will try to understand through the instructions, and then while doing the instructions, knowing about the instructions, we will understand its architectural internal behavior. Okay, and that time only we will try to understand what is a machine cycle, how much time is required to work out or execute a particular instruction. There you will understand the topic of what? Delay, right? And how we can avoid that. All these things will come into picture. But prior to that, the instruction set of 8085 is basically divided into arithmetic things, logical operations, and that's all. Arithmetic operations and logical operations. So arithmetic operations. Okay, I just say mathematical operations. Tell me what is arithmetical operations? First one comes to mind, add. Second one, subtractions. Third one, multiplications. Fourth one, division. Isn't it? Is that correct? Or not? Any more arithmetic operations are there?
No.
Anything else? Please tell me. Yes. Right? Only these four. But unfortunately, these two don't exist in 8085. Fourth thing, 8085 deprives of this one. These two operations are also performed through this only. If you remember the complement methods we used to teach early in your basic electronics, that is because of this. Because this commercial kit doesn't have these two operations. So please wipe out that. I cannot teach you this in this one because 8085 doesn't support this. 86 supports. Afterwards they could do that. Okay. So addition and subtraction. One more is the mathematical one, arithmetic one. It is increment. INC or and we'll say increment or decrement. Increment or decrement. These two are there with that. So basically it has only 4 instructions: addition, subtraction, increment or decrement. With this 4, arithmetic is done. Mathematical is completely done. Is that fine? We will understand exactly what addition is done, what subtraction is done, how increment and decrement operations are done. I will explain you. Okay, only this 4, increment and decrement. Next comes logical. What are logical? We have OR, we have AND. OR and AND. What else is there? What else is there? What do you think? What else can be there? Could be there. It has another one, XOR. Okay, these 3 only. Other than that, it doesn't have anything. Only these 3 operations are there in 8085. You will be asking XNOR, then NAND, NOR. These are all missing out. 8085 doesn't support those logical operations. Only these 3 it will support. Another one it supports rotate. Rotate. Rotate means what? Rotate right, rotate left. So many are there. Bit by bit rotations. That rotation it can support. Another one is compact. Now you should be understanding. With this huge, with this particular is limited scenarios, they are able to work out. Another one is complement. These are the 4. 1, 2, 3, 4, 5, 6. With this, all the logical operations are also done. Right? Apart from this, we have branching operations. What is branching? Already I have given you. Branching means what? Where to jump. So I already told jump. Jump to another branch. Jump to this location. Come from this here. Then afterwards, another one is you call. You call. This word is familiar? Whenever the subroutines are called, is that fine? Return. This word is familiar? You guys are good programmers. Return. Call is always supported with return, isn't it? And then repeating or not?
Yes, ma'am.
So call is supported with this or not? Return or not?
Yes, ma'am.
Call is supported with return. Okay. I heard that you guys are very good programmers. So call and return will come with the subroutines. Here also, with this assembly language, with this limited operations, we can perform so many tasks. Let's go to the basic levels and we will also do. Don't worry. Right. So mathematical, logical, and branching. With this, the whole instruction set is framed. Okay. But we should understand the assembly language syntax, which we will call it as mnemonics. The syntax. So our next job is to understand what is the syntax and what is the meaning of that and what is its operation code. That's all. Then we will understand how it executes in that architecture. This is how we have to enter into the 8085. With this, these are our methods. And the mathematical operations, this much I can do. And logical operations, this much I can do on the bits only. And that too, by the way, it's only on the bits. Right? And then this much jumpings I can do, branching operations. With this only the code has to be written. And by the way, the memory size is only 64K. Within that only it has to complete. Memory size is 64K. These instructions also has to be in that, as well as the execution also has to be done, and the results also has to be allocated in that. That 64K only, not more than that. Correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
Pretty heavy, right? Right? Or otherwise, the olden era has lived in a denial. That's how you felt? Yes. Are you feeling that way? Arey, I'm asking simple question. You can openly tell your what? Your views. Isn't it? Just imagine 8085 processor with the 64 kilobyte memory, and in that portion is already allocated to the instruction set. Little more is left. With that itself, the task is being performed. We will have done that. Masters and doctorals also with that 8085 kit only. And now we are having workstations. There also our kids are not even doing anything. Simulation work, nothing. Is that correct? Here also silence only. You guys will barely speak or what? Already you are not coming to the campus. If you hooray, nicely enjoy at home only. Isn't it? Yes or not? Is that correct?
Yes, ma'am.
Very good. So, none of the people are talking about second years and first years here. And exclusively they forgot about dual degrees. God knows. And moreover, so that obviously. So, second thing is what? Second thing is something else I wanted to tell. Apart from this, about your final exams, there is no time. Any time is given. Timing is given for you at present. Yes. So,
Ma'am, what time?
Timetable. When you have to come, when will be your final exams, anything?
Ma'am, the
Ma'am,
original circular and
Oh, everybody actively participating.
Ma'am, in May we were about to return. Then after that, in June, our exams will be there.
Oh, May you will be returning and June your exams will be there, provided if at all you will complete this third year and final year. And I'll tell a story. Don't tell anybody. Yeah. Recently what? Forget it. Last 4 days, even while I'm speaking, also I'm taking water in between. If you have noticed, what happened 3 days back? There's a who are in Odisha, you can understand, right? There is a forest fire or something, isn't it? Yes.
yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes, ma'am.
What happened because of that? Rourkela, what happened? I don't know about other cities because I'm in Rourkela only. Na? Continuously, sun has come. There is a dust cloud completely covering your beautiful campus and whole Rourkela city itself. Right? Like we can really feel that dust cloud is there right upon our head. Seriously. Right? So that's how last 4 days it is here. Last 4 days. Okay. Then, okay. So what happened? So yesterday, like my husband works in RSP. So they will have morning conference calls. He's a GM, so he gets the conference calls and the confidential work and all will be going on. So that time, sorry, normally I don't say that, but since you guys are not there here, and then I want to really explain what exactly scenario here. That's why I'm sharing this. So they were talking. I am overhearing. So normally I don't do, but I overheard. So there is a gas leakage also parallelly going on. Right. So day before yesterday, this conference call. So I couldn't understand what is that gas leakage and all. Normally they have that gas leakages in the RS, right? And then that's a poisonous gas, right? It's nitrous oxide. So it also entered into the cloud. So what happened? Rourkela has double dhamaka. One is the Simlipal smog, okay, and then in that we have the poisonous gas also. Am I boring you guys? If you want, you can.
No,
No, ma'am.
No, ma'am.
continue.
No, ma'am. Ma'am,
It's very
continue.
interesting. Now, when I tell you to acknowledge this, that you will not acknowledge, idiot fellows.
Yes.
All are same here. So what happened? So we have double the mark. So yesterday there was a holiday, right? I was working out for something and I stay in township. So we will have a more effect rather than NIT people. So like all of a sudden I felt breathless and I literally couldn't like one sort of congestion sort. Then afterwards I got head reeling and then puked also. So I was thinking like, what is wrong with me? Am I infected with COVID or what or something? So afterwards I felt restless and I slept off. Then afterwards evening I heard that in the township so many people suffered with this. Suffered with this sort of congestion, then head reeling, because we got that effect so much. Like we had the cloud just like we can see the cloud, poisonous cloud, or right on the top of our head. So still it is there. like that only. Like we outside no sun. Sun is very very dull. We have only smog outside with the poisonous gas inside. Seriously. And now, yesterday night there was the echo team from Delhi. So to investigate what's exactly the scenario here, and then they are charging the RSP like anything. That is also going on, and it seems like the poisonous levels have gone to very very maximal levels. So we can you people can see us or you cannot see us also, right? By the time you come back. So some sufficing work is going on. I think today some other remedies they are doing, but still I don't know whether it will be completely eradicated or 2 more days it will take, it seems, because of that gas leakage. You can think of another Bhopal scenario here, little bit related to that. Okay, so you guys, by the time June you will do, by the time we will all die. Okay, so you be happy. Exams won't be there. Seriously, I'm not joking. This is really so many of you might be following your senior runners, right? Your seniors who have come, you ask them whether how they are feeling also. So many students today went to CWS, to have their asthmatic check. So many asthmatic patients got triggered because of this breathing, continuous breathing problem. Like we will be okay for some time, afterwards like we will feel heavy. And outside also, like total, like yesterday it was Shivaratri and there is no crowd outside, completely they have banned, like stay inside. That's a different way. They are telling COVID and all rules and all regulations we follow, but no, it was other one. Like total gas scenario was so horrible. Now I think slowly it will go, but it will take 1 more week for us to subside. So you guys don't come, be happy, stay safe at home, right? So we will anyway kill ourselves here, right?
And
So
take
what
care.
next? You people, you're so happy. I'll go definitely. So
And
let's see what we can do. Thank you, dear. So what we'll see if Monday. This all story is what Monday also I'll take class if I'm allowed, right? So which time, Shweta, you'll allocate?
Ma'am, Monday there is a class already.
Whose
Your
class?
class is there. Ma'am, their
3:15.
class, I mean your class is already there at 3:15.
Okay. So till evening, if you want to wait, I can come back and tell you with some stories also what happened on Monday. I'll be like your Oracle news and all. Hey, it seems I don't know that Simlipal is continuously burned and the white tigers have been died. It seems like they are dead completely. Is that so? I don't know. Your HOD
No,
ma'am is
not
telling that
completely.
she's.
No, not completely. Ma'am.
Oh,
Yesterday,
your HOD.
yesterday or day before yesterday, it rained heavily.
Oh. No. There are some points, it seems like sometimes they got rain and some points are still. And by the way, we have Saranda forest also on fire. Saranda is very near. No? How many guys have seen Saranda? You didn't have the time to
Outskirts
go.
of HD.
Yeah, Saranda forest came into news when there was a big terrorist attack. No, there was, like, you guys are not born or you might be very small. That time, Saranda, there were terrorists there. Okay, so that time Saranda forest was in this one, but still today morning onwards it is on fire. It seems. I have no clue. But your ma'am was telling, like HOD ma'am was telling that what is that? Your Simlipal has a lot of white tigers and so many died, it seems. So she was telling. So she belongs to that place and she was telling so many white tigers have been totally done. And by the way, did you guys see the International Women celebrations? You see, you guys,
Yes, ma'am.
you see, you can see the marks of our faculty members, research scholars, everyone. You guys saw? No one? Shweta?
No, ma'am, I haven't seen.
It's in YouTube. You can see. International Women's Day. Okay. And I can tell you that. And all our faculty so nicely they perform so many skits also. Unfortunately, I'm not there because they didn't shortlist me. Nothing like that. So I was not there actually there. So they have done a lot of drama, song, then fashion parade, everything. So whatever you guys have to do now, everything they have done that. Like we missed you and they did for yourself. They did for themselves for you to show and then streamed. Please check out in YouTube. Okay. So send some good comments to the professors. I mean, if you like it, that's all. not necessary, but
Sure,
you can.
ma'am.
Yeah,
Okay,
we
you can
like it.
see your HOD ma'am, Dean ma'am, everybody are, I mean, exclusively electrical department, everybody danced, I think. I mean, I'm not there. So you don't search for me in that, but I was not there. So many else are there. Like you can check out. Electrical is very vibrant, it seems. Even they have conducted some sports also. So many things they have done. Like our faculty really got bored and then they are using their time like this. Forget it. Okay, so hopefully June, if you guys come back, we will try to work out, but still chances are there for online tests for you guys. Right? Online is better, na Shweta?
Yes,
No
ma'am.
comments.
Definitely.
No comments. Definitely. Very good. Very good. And no exam at all. We will give you degrees. That's much better. And
Yes, ma'am.
so, yeah,
Yes,
good,
ma'am.
good.
Yes, ma'am. Please
Very
no
good.
comment.
So, that's great. I will also do that only. Okay, chalo. Enjoy your weekend. I will get back to you on Monday. Good day.
Thank you, ma'am.
Thank you, ma'am.